The purpose of this video is to demonstrate how to calculate normal and shear stresses in rectangular beams. We consider a plywood beam made of n glued layers. Each layer has thickness h, and the wood has strength S, and we do not differentiate between tension and compression. And our task is to determine the strength of the glue, the minimum required strength of the glue. And we do it in a setting where the beam is simply supported and the Q and L are given. This is a very simple setup, and the shear force and bending moment diagrams are very easy to construct, and I recommend that you check that my answers are correct. And the important aspects of these diagrams are that the maximum shear force is QL over 2, whether it's positive on the left or negative on the right, it doesn't matter. For shear, the magnitude of the shear force is important, and the maximum bending moment is in the middle, and it's equal to QL squared over 8. Let me begin with the normal stress calculations. We have the standard formula and we have the cross section. And here I would like to introduce capital H, the height of the entire cross section, and of course capital H is equal to the number of layers times the thickness of one layer. For this cross section, the maximum normal stress could be computing by maximizing my over Iz. And here we have QL squared 8 comes from the bending moment diagram. H over 2 is the maximum Y for the chosen cross section, and BH cubed over 12 is the moment of inertia. And when we put it all together, we obtain this answer. And you can see that the answer is expressed in terms of capital H. That's what matters for this answer. Now we can use the maximum stress to compute the maximum Q. All we have to do is equate sigma max to the strength, and this gives us the expression for the maximum load the beam can sustain. Now let us proceed with shear stress analysis. So we have the standard formula, and what we would like to do is to determine what is the maximum shear stress in the glue. We suppose that there is glue in the middle of the beam where the shear stress is maximum. And to calculate this maximum shear stress, we take QL over 2 from the shear force diagram, and then we calculate the maximum Q. It corresponds to A star, which is equal to exactly 1/2 of the cross section. So Q max is calculated as H over 4. That's the distance for the centroid times the area of A star, which gives us BH squared over 8. Now we can put it all together with the moment of inertia BH cubed over 12, and we obtain that tau max is equal to 3 QL over 4 BH. Again, observe that it is sufficient to know what's the thickness of the entire cross section, capital H, rather than the number of layers and the thickness of each layer. With this result, we're ready to calculate the shear strength of the glue. First, we recall that tau max has been calculated, and we also calculated Q max dictated by the wood. Now we will make a very natural step and say we want to choose the glue so that it doesn't undermine the wood. What this means is the strength of the glue must be such that it can sustain Q max dictated by the wood. So all we have to do is to substitute Q max into this expression for tau max, and this gives us the value of tau max equal to HS over L. And therefore, we claim that the shear strength of the glue must exceed H over L times S. Again, nothing here depends on little h and n separately. So it is sufficient to identify the total thickness of the plywood, how many layers we have to form that thickness. It really doesn't